What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to wrap up going over IP routing. And we're going to go over a very important section, okay? I've had plenty of students in my in-person boot camps that go test. And of course, they don't talk about the test because that'd be against the Cisco NDA that you sign. But they say that learning how a router chooses which routing or which destinations to put into its routing table is a very important thing to know. So we have our own video dedicated to it. So let's kind of get the lay of the land, right? What we're talking about is a router. Let's say R1. It has three different neighbors, R4, R3, and R2. And each one of these knows about 10.10.10.0/24. And so they advertise, so R1, they know about this network. One router uses OSPF, one router uses RIP, one router uses ERGRP. Which way or how is R1 going to send traffic? Which next hop is going to go into the routing table? Because we know we got to place this in the routing table, but how do we reach it? Are we going R2, R3, or R4? We're also going to go over this. Now, let's switch it up a little bit. We still have our neighbors. And let's say R2 knows about 10.10.10.0/27. R3 knows about 10.10.10.0/24. And R4 knows about 10.10.10.0/25. Again, this one's OSPF link. This is a RIP link. And this is an EIGRP link. Actually, let's change that. Let's make RIP up top and EIGRP right here. And now let's say from its LAN, R1 receives a packet that says the destination IP is 10.10.10.1. Source IP doesn't really matter, right? How is this router going to forward traffic? Well, 10.10.10.1 could be part of any of these networks. So how does the router forward it, right? Because all three of these are different networks, because different prefix lengths, different subnet masks, different CIDRs, right? Which way is this packet going? It can't go out all three, right? So we're going to go over how a router does this selection. And there's three rules. If you don't remember anything else from this video, there's three rules. The rule of specificity, which trumps everything. This is chronological, right? The lowest administrative distance is next if this rule is out. If this rule gets out, we're all learning about one routing protocol, the lowest metric wins. Okay? So let's dive into these rules. These two rules are easy to understand, I think. If you're learning about OSPF, which has a 110, and ERGRP, which has a 90 administrative distance, it's going to pick ERGRP. But we have this first rule here that trumps everything, the rule of specificity. So what is that? This is saying that when you receive a packet and that destination IP, if that destination IP falls within a longer prefix length, it's going out that path. So the rule of specificity is if a destination IP is inclusive of a longer prefix, it chooses that route no matter what. So let me stop talking about it and let's show you. So let's get the lay of the land real quick. Okay, so we have R4, R5 in the middle. It's learning about four different networks. We can see the network address is the same for all of these. So it's learning about 172.16.0.0/27/26/25/24. ERGRP AD is 90, static is 1, OSPF is 110, RIP is 120. Now R5 has received a packet from, let's say, PC1 here, and PC1 wants to reach 172.16.0.4. So what does R5 do? What routers all do? It checks its routing table and sees where it's going to send that packet. So where is it going to send it? We can see here that RIP has the worst administrative distance, right? But what rule trumps that? The rule specificity. RIP has this prefix here, /27. That's the longest prefix out of all these. And what do we mean by longest prefix? Well, if we look at the binary that CIDR, we know there's 27 what? Network bits. And then 5 host bits. If we look at the rest of these, there's less network bits. So this is the longest prefix length, the longest network subnet mask, right? Or network it has in its routing table. So now if we break down this IP address into binary, so I don't care about these first 3 octets. Let's break down 4. What is that in binary? Actually, let's clean this up a bit, right? Let me just clean this up. And then take a step back, right? So we know the rule specificity. So if we take a look at this RIP route, we take that CIDR, that prefix length, there's 27 network bits and then 5 host bits. And our router needs to know where to send this. It's going to use that rule specificity. And it's going to choose that RIP route because it has the longest prefix inclusive of that destination network. If this was a /31, it couldn't use it because that doesn't belong in that network, this IP address. So now if we break down that IP address into binary, we don't worry about the first 3 octets. We're not working in that, right? Let's convert that to binary. So that's going to be 0. See, that's 16, 8, 128, 64, 32, 16, 8, 4. So that's actually going to be a 1. And then the rest are zeros, okay? So we see this host portion falls within this prefix length here. Now, there's only 5 host bits here. Let's say that this ERGRP was actually a /28. We would prefer this /28. Why? Because now this still falls within these host bits, but there's less of them. So this is considered more accurate, okay? So really, if we break down the binary, we kind of start to understand this rule specificity, right? It decides that, okay, well, I better fall into this network because it's more specific to me. Now let's say that, let's go ahead and get rid of this. Let's say that this traffic was destined to .0. Let's say 18. Or no. Let's say this falls within .0.34. Well, let's break that down. So again, we're going to convert everything to binary. We have our RIP /27 here. Rest zeros, right? And let's break down 34 into binary. I'm going to need my chart, guys. So that's 0. Zero. That's 1. And then we can stop right there, right? It takes 5 bits. 5 bits, excuse me. We can see that, or that takes 6 bits. We can see that that falls outside of this range. You see that. It takes 6 bits to get that number, where we only have 5 host bits available here. So it's outside of that network. Little subnetting, right? But then if we break down this slash 26 right here, or this slash 25, you can see it's going to prefer that slash 26. Why? Because these 6 bits fall within here without that extra host bit here. So it trusts this more. That's why that rule of specificity matters. Because at the actual routing forwarding table, right, that forwarding information base or that router information base, the destination IP that falls within a subnet more closely, meaning there's less host bits to have this be a part of it, it's going to trust that more. So that's the rule of specificity. So if we got if we have a IP address destined to .0.34, it's not going to choose that RIP route and instead now choose this OSPF route, because now that's the longest prefix inclusive of the destination IP. Awesome. So now let's say that all this was equal, meaning get rid of this, and all these are slash 24. Now which way is it going to go? It's going to go the static route way, because that is the lowest administrative distance out of all 4. Now let's get rid of the routing protocols. Let's say we have a slash 24s and it's just ERGRP. Well, now it's going to go off the lowest metric. So if these were our actual metrics here, 0 would be the best, right? So it'd go out gig 03. Awesome. So that's how you explain, or that's how the rules work. If a destination IP falls within the longest prefix, it's going that way no matter what the administrative distance is. And this is kind of exactly what a routing table looks like. In our next section, going over static routing, we're actually going to take a look into a routing table so I can show you what it would look like in a real world environment on a real router, okay? So this is going to conclude our last section of IP routing. I hope all of this was informative for you. And again, for the CCNA exam, if you didn't learn anything from all that demonstration, try to memorize these rules. Number 1, the rule of specificity. If all things are the same, it's all slash 24, the lowest administrative distance. If all the routing protocols are the same, the lowest metric wins as the route to be placed in the routing table and forwarding that traffic. So I want to thank you all for viewing and stay tuned for our next section as we go over static routing.